Hello guys, my name is Andrew and I'm going to help you solve the LeetCode 773 sliding puzzle problem, which is the daily LeetCode problem for November 25th, 2020. And so to start off, um, the problem wants you to basically do a sliding puzzle where you're going to move the numbers around the empty square, and the result is you want to have um, the the board be in order of 1, 2, 3, 4, 5, 0, and once you return back the minimum number of moves required to get there, or else return -1. And to do this, we're going to do it using a breadth first search. And so to start off, what we want to do is create an adjacency mapping. And here you'll see me go through and make a couple, and you'll quickly see the pattern. Here with the first one, you can see at index 0, I'm in example 1, I'm calling it the number 1 right here. But if this were to be 0, the two locations they could swap with would be the 2 and the 4. So this would be 0, 1, 2, and then 3 for a 0 index array. And you'll see here as I continue through, the next one could be able to swap with these indexes being the 0 index, and so on. And let me quickly put these together, and you should be able to keep seeing that same sort of pattern. Five, and the last one here. It's a typo up there. And for the last one, it will be 2 and 4. So here we have the adjacency list, and now we can do the actual breadth first search. First thing we need to do is we want to treat this board as a single dimension. So we're going to, instead of having it be a 2D array, we're going to have it simply be one array. And thankfully in Python, it's pretty simple to do this. I'm going to call it B. I'm going to be equal to, we could simply do board 0 plus board 1. And this works because in the constraints, we see that this is always going to be this 2D array. It's always going to be the same size, and we can just combine them here. And now for the variables needed for the actual breadth first search. We're going to use a q, which will be a dq in Python. And for our initial value, what we are going to do is we are going to add a couple. And let me show you this. We're going to put in the comments here. For this breadth first search, the first index we're going to use is we're going to use I, which I will be the index of the empty square. Using example 1, the index would be 0, 1, 2, 3, 4. It would be the fourth index. That we're also going to pass the board at that current state. And then at the end, we're going to get the current length of the path in the breadth first search. So to start off, we're going to give the initial value of b.index, parentheses 0. This will return the index of where the empty square is. We're going to get the board b, and the length right now is 0. 0, and then for visited, we're going to maintain a set for visited to make sure we haven't reached this state before. So we're going to do set bracket, and then we're going to add the board here. In Python, it is not allowed to add an array to a set because in the backend, a set is just a hash map. What we're going to give it here is a key, and you cannot use lists as keys in hash maps. So you can't use it on a set either, but we're just going to simply turn the board into a string here to create this first set. Now we can do the actual breadth first search. Here we can do the BFS. So while q, what we can then do is we can q dot pop left. And in the depth first search, we're going to just pull out these different variables. So we're going to have the I index, we're going to have the board, we're going to have the length. Now we can now check if this is satisfies the condition for passing. So we can do if b equals 1, 2, 3, 4, 5, 0. If b equals this, we are done and we can return the length. And if it's not passing, we can continue onward where we're going to check and do the breadth first search and check each adjacent index. So what we can do is we can do for j in adjacent mapping for this bracket of I, because this is where the 0 is, where we can begin to swap them. First thing we're going to do is swap them, and I'm going to use a new board variable to accomplish this, using basically taking a copy of the original board array, calling it one called new B, and here's where we're going to swap the indexes. We're going to say new B I, comma new bj equals new bj, comma new bi. And this basically takes that board and swaps those two variables, swapping the empty square with that number, which is going to be one of the adjacent squares here. And we then need to check if this board has been visited before. And to do that, we can check if, and we're going to have to do the same thing since arrays are not allowed to be keys in maps or dictionaries in Python. We're going to do the same thing. So we will say if quotes dot join new B is not in visited. First thing we can do is we do visited dot add. We're going to add this same guy here, add the string. We can do visited dot add. And then we can do q dot append. Here we'll do this. So we're going to be passing in j as a new index. We can pass in new board as a new board, and we're going to do length plus 1. And here we have the full breadth first search. Just to review, we're using a queue to maintain the nodes that we need to check, and we're retaining visited to make sure we aren't doing any duplicate work. While there's an element in there, we pop left, we check if it satisfies the condition. If not, we then check all of the nodes that are adjacent to this one, doing the breadth first search. And at the end, we also need to return -1. Or if this goes through the whole tree, can't satisfy the condition, in the end, we will return -1. So we can run this, see if I have any typos. Oh, looks like I do. Yep, breadth double equal sign. There's another one, visited equals set. Instance, oh, sorry, big bit of a typo. We need to typecast this array to a string. And I'm using that in a couple different locations. So let me quickly update that. Should be happy now. And there we go. We are passing. With that, guys, that is the problem. Thank you.